Now if we start the simulation, it will flicker pretty rapidly, much faster compared to the 1000 delay. So this is the intro program which I wanted to share you guys in the Tinkercad. So I hope you learned how to blink an LED using Tinkercad. Now going back to the slides. Yeah, so these are the two commands which we used to blink the LED, like digital read and digital write. If you have any doubts, you can put in the comments. And one more thing which I want to say is you have a component called the breadboard. So how the breadboard works is you have the breadboard. Okay, first I tell you the main use of the breadboard. The breadboard is used to reduce the amount of wiring you have to do. Say you have a lot of components. So instead of wiring up every single thing, you can use a breadboard and connect them accordingly, which we will do in the next couple of minutes when we do our next program with the buzzer and all. So here on the power rail, you can see all these entire vertical strip is connected together or shorted together. So if you connect uh, at a one end of the power rail, the other end of the power rail will also get the same amount of voltage. Similarly, the ground voltage. So these are like horizontally connected, and the ground rail, no, sorry, the circuit area, which is the green part. These are connected vertically. So each set of 5 pins is connected to each other, and in the middle you can see a white area. That area is basically called a clearance area. Like the green part on one side and the green part on the other side are not connected to each other. So this is the breadboard, and this will be extremely useful when you are making more complicated circuits. Yeah, and these were the connections which we made just now also. And yeah, so now Skandan will take over from here, and thank you for listening. Yeah, hello Skandan, you can start.
Yeah, I'm there. I thought, I mean, I was waiting for you to end the share my
Yeah,
screen.
okay, fine, cool.
So, guys, am I audible?
Yes, yes.
Yeah, fine. So, good morning, guys. I'm Skandan from Mechanical Engineering Department of 2021 batch. So, I'll be taking on the topics from here on. So, beginning with serial monitor. Yeah, let's see what does serial communication mean before we take a look at the serial monitor. So, serial communication is the process of sending data sequentially, bit by bit, from the user to the Arduino through USB port, which is again the hardware that facilitates this connection. So serial monitor is thus the interface between computer and Arduino, computer as in the user and Arduino, which basically acts as the point of communication between the two systems. So now again, it's important to understand the term serial receive buffer before we delve into the uses of serial monitor. So any idea what is serial receive buffer? guys?
You guys can just type in the chat if you want.
Okay, so serial receive buffer is the location where the data being transmitted from the computer to the Arduino is stored temporarily before getting into the memory of the microcontroller. So the first use as a programmer, we all may have used the print statements in the loop to understand the control flow. So for serving a similar purpose in serial communication, the serial monitor can be used. Secondly, it can be used for sending and receiving instructions to the Arduino and back to the user. So moving ahead, we have the serial monitor commands. So let's start with the basic command serial.begin, which opens a channel for the communication, sets up the serial port facilitating the communication. So hence it is written under the setup block of setup part of the code, in which Fardeen discussed a while ago. It takes in baud rate as a parameter. So guys, any idea what is, like anyone knows what is baud rate? Yes. As Roshan rightly points out, it's a fancier name given to the rate at which data is being transmitted through the serial port in bits per second terms. And the default value of this baud rate is 9600, which basically means 1200 bytes per second. So moving on, we have the second function, serial.print, which is again used to print a message in the serial monitor. And this is one of those functions which is used extensively for debugging the code in case where we encounter errors and want to change the output to a desired one. So then we have the serial.available function, which gets the number of bytes available in the serial buffer from the input stream. So hence it returns a zero if there is no, there is an absence of any data. Moving on, we have serial.read function. So in order to better understand this serial.read function, we use it, basically it is a function that takes input of set of characters from the serial monitor and whose ASCII value is internally taken byte by byte. That is basically character by character. Let's say we've given the input of a word flow in the serial monitor text box, which is shown here. And then we click on send. And we have the serial.read in a loop where we check if serial.available. That is there if the user has provided any input in the serial text box. So in that case, byte by byte, it checks the input and returns, internally returns the ASCII value of the input. So first, the ASCII value of F goes into the, from the buffer is taken into the memory, and then the ASCII value of L is taken into the memory from the buffer, so on and so forth, until the next line character is encountered, which is again the end of line character. Moving ahead, we have buzzer. So buzzer is a sound producing device that can act as an indicator or signaling component in the circuit. So they can be categorized into types such as piezoelectric, which is based on the principle of piezoelectric effect. Here, any idea, folks, like what is piezoelectric effect? Right.
Yeah, you can continue.
Exactly. Like as Akhilesh points out, it is production of electricity by stressing or compressing certain type of material, which in our case is a special type of ceramic. Or the buzzer can be electromechanical, which consists of a metal disc on a magnet in basically in a magnetic field, whose magnetic field is varied so that the disc rotates. Yes, this reminds of you of a J advanced question that we might have practiced. And then this produces sound. Basically, change of form of energy from magnetic field to sound. So, is there a possibility of this sound being something soothing? So, hence for producing tunes in the buzzer, we use special kind of signals, type of signals that are intermediary between analog and digital, kind of a hybrid signal, which are PWM signals, pulse width modulated signals. They produce swiftly changing between the switch states, which are high and low. So they're not exactly analog signals, but yet they, uh, on an overall scale over a time period, their function or the function is not similar to that of a digital signal too. The fraction of time period for which a switch remains in the high state is referred to as duty cycle. Hence, in this diagram, we can find that for 50% of the time, uh, time period, the state is high. And for the rest 50% of the time period, the value is low. Hence, on an average, 2.5 volts is the output that is produced, which is again a reduced average power consumption as compared to a digital circuit where we would have got 5 volts per time period. And yes, moving on, we have two Arduino commands pertaining to the PWM signal, which are analog read and analog write. So analog read is a function that reads the analog value that is being input from the analog pins. I mean, a component connected to the analog pins whose value doesn't change from being low to high, but changes through a certain series of values. Similarly, analog write is a function that writes an analog value to an Arduino pin. So basically, it functions a similar way as digital write, but now it's the analog pin and the value needs to be between a certain range, and it is not 0 and 1 anymore. To better understand the importance of buffer and PWM, let's go on with a project where we'd be using a buzzer to monitor LED's brightness. So I would like you guys to move on to Tinkercad, if at all you have opened it, or let me give you some, yeah, 15 seconds to open the Tinkercad and log in. At all, you've left out in the, you thought the slides before. Let me just open the Tinkercad from my side too. So my screen is visible, right? Tinkercad screen.
Yes, it is visible.
Yes.
Yeah, good. So, starting off, we will obviously need the Arduino board, which is the brain of all the activities that we're going to perform. Then we would need the buzzer. So in our case, it is the piezo buzzer. And I don't know if you guys are very much familiar with this thing. Like you can, in this case, we have the ground, I mean, the negative terminal towards this side, but the ground towards this side. So in order to make it look even neater, you can use this command so that the mirror image of this thing is taken, and thereby you can connect the negative terminal directly to ground here. Let me give a color coding of black. Similarly, the positive needs to be connected between 2 to 13. So let me choose a pin at random, such a 9. And yeah, I'll choose red color. We'll be using a breadboard here for taking input, I mean an analog input. So yes, there we have the breadboard that was being discussed a while ago. We just connect the ground, or yeah, for the connection of ground. Let me take a photoresistor, which we'll be using in this particular project in order to illustrate the changes of values in an analog manner. Let's say it's so basically photoresistor is a light sensitive resistor component whose resistance decreases with increase in brightness. So it can't be either 0 or 1. So and it takes the range of values, in which case it's an analog input. And we're going to use this analog input to change the values of the buzzer. I mean the values that are being input to the buzzer. So hence, moving on, we need to connect these terminals to the required positions. And the function of a breadboard in most cases is to increase the availability of pinpoints. So if I directly use this ground to multiple pins, it's a bit difficult to see and visualize, as well as a bit difficult in a hands-on session. So we use a breadboard for that particular thing where we reduce the dependence on the pins directly by using an interconnected board. Let me start off by connecting ground. Then we need to connect one of these analog pins, let's say A0. Giving it a bit of color coding, let's say I'll give a green color to this and the top was color to this. Then again, since it's a low power consuming component, we need a resistor. So, and yeah, uh, we might have to tilt this in order to use it. For tilting in Arduino, I mean, Tinkercad, we have this rotate option, which tilts your component by 30 degrees every time that you click on it. So let me place it here so that you have this to complete your circuit. And finally, oh, I connected this to ground. Actually, this needs to power the circuit, so this needs to be 5 volts. And similarly, this needs to go to the ground. So that now the connection is complete. Let me just complete the circuit. Yeah. So moving on to the code. We first need to initialize a few pin names so that we get on to give the pin more. So let me initialize the A0 pin where we have connected the photoresistor as, let's say, PH. Similarly, let us initialize the pin
Skandan,
where,
just
yeah,
Skandan, just show that
yeah,
diagram also.
yeah. This is how your
Now
final circuit.
you can just zoom out and then show the code along with it.
Okay, yeah, sure. That's it. Is it fine now? Like, is the circuit visible clearly?
Yeah, it's okay, I guess. It's okay. It's okay, right?
Both the code and the circuit are visible. For the photoresistor. So one of the connections that is being made is connecting it to the high voltage. Basically, it's the anode that is being connected to a higher voltage, and the other terminal, let's say the cathode in our case, is being connected to ground. But this is being done to complete the circuit. The resistance here is a special type of resistor, which I'll be talking about later in the session, that is being used to initialize the value of the photoresistor to a particular value rather than allowing it to take any value at random between the ground and phi. So there's a special function devoted to this particular resistor over here, so which I'll be discussing later on in the session. And yeah, this is to get input from the photoresistor to the memory of the Arduino so that we can use it to power or control the buzzer. Hope that answers question to an extent, because I'll be discussing about that particular resistor part and during the session again. So yes, moving on with the code. Let's give a name of BUZ. Let's say B, the pin number 9 to which your buzzer is being connected. And now we need in a variable, let's say even to be initialized, which we'll be using in the code from here. And since we need to check the kind of a debugging needs to be done for this code really. So let me bring in the serial monitor by initializing. So what is the border that I talked about just now? Can anyone put it in the chat? There's a particular default border that I told about. Yes, exactly. Which is 1200 bytes per second, or 9600 bits per second, which is 9600 in our case, which has been. And we need to initialize the pin modes, which are TH to give input and P to take output. Then moving on to the loop part, which repeats every once in a while after we begin the program. So why did I take that variable? Should have been a dot variable. So that is to give input to the buffer. So uh, I'll be reading the value that is being input from the photoresistor at the pin number A naught of PH. That is also taken as output onto the serial monitor screen in order to check if really the values are being changed properly. Let me give a delay of some 100 milliseconds just in case to ensure this functions properly. So what should be our next step? Like I've taken the input from the photoresistor. Now, what is that next step that I should be taking in order to get a particular tune or tone or buzzing sound on this from the buzzer? Any idea? I've partially given a hint. Let's say I given a hint of using a conditional statement. What should be the condition? Let's say any idea again? Yeah, that's actually what we're going to do. So more than being between a range, let's say it is less than a particular value. Range of 1000 to 24. I mean, it's between some 250. It's less than 250. In which case, I'd be introducing a new function called tone, which will take three parameters. First parameter being the buzzer pin, then the frequency at which you want the buzzer to operate in. So let's say that is 250. And the third parameter, which is often neglected, and it is the duration for which the buzzer remains on. And is the does have a default value, so I'll be not mentioning it, but the third parameter is duration. Just remember in case of the same to market. So if the value that is being input from the photoresistor is greater than a certain value, we are resorting to having no tone, or basically stopping the tone. So we only need the buzzer pin where we are giving the input. So I'll begin the simulation. Was the sound audible? Yes, it was too loud. Sound audible, guys?
Yes, you're audible.
My sound, but once I started the simulation, there was a sound because the initial value of var variable will obviously be lesser than 250. There will be sound produced. So was it audible? I don't think it was. So suggestion is turn down your computer's volume. This thing can be really loud. So I'm going to start the simulation. And yeah, if at all your friends are seeing it and there is some kind of internet connection, tell them that it's going to be really loud. Yeah. Yes, the sound was audible now, which is the buzzing tone that will be produced by this as a signaling component when the analog value, right, here is taken as input. So I'll be restarting the buzzer again in order to change the value of photoresistance and check if it's really working. So I'll better say again, hold on with me and reduce the volume of computer. There we see. Once we increase the light, that is light intensity that has been falling on the photoresistor, we reduce the resistance and thereby the analog read values increase. So above a certain value, which in our case is 250, we see that there is no output that's being produced by the buzzer. So if I tend to reduce it less than 250, so that was all about the project where we use the buzzer, the code for which has been given in the slide. So any doubts in the code? Well, yes, once you have an account and you're done with running the program, it gets auto saved. You only have to change the name of the project, which would be given by the Tinkercad at random. So in order to identify that this was the project that you did, so only that part has to be done. I don't think you need to specifically save the project. So is there any doubt, guys? So you guys have seen that this function, I mean, this particular component can produce sound, set to a sound at a particular frequency. But do you guys believe that this can produce even a song as output? Other pins photoresistor? Yes, I mean, it's just inverting it. Even in case of LED, we had both the pins in. So yes. Oh, find many more answers now. So one demonstration of song would be this song. So I'll be again sharing the sound. So hang on with me. Or I'll try to reduce the sound in 100. Guess this won't be loud now, but just in case. So there we had a demonstration strong. So basically, in this code, what they've done is to define notes similar to that in a keyboard or in any instrument. But basically, it's the keyboard or piano, wherein you can find A2, AS2, A sharp 2, B2, C3, C sharp 3. So these have been assigned particular frequency values that they're going to access. So I guess it's a piano because the number is 9. I mean, it's a keyboard because it number doesn't exceed uh, some 84, which I guess is the case with the keyboard only. So then they've given a list of values or an array of values for the notes that needs to be played at a particular interval, which again, as a parameter, they have given in the array for the duration for which that buzz sound should retain. So 4 is a quarter note. So basically, they've even found out that a quarter or whatever is the value that would be input if you put 4, and eighth note, which is again semi-quaver, will be input if at all you give 8 as the input. So in the setup, now they're using a for loop to take the input, I mean, to traverse over the array, and they would give the input of these array values into the tone function that we discussed in the code before, to the 8th pin. So the pin that was initialized, you can say, that has been initialized is the 8th pin. And there has been a pause between the notes, which is the note duration into 1.3. So they've used the duration for both purposes, one for the tone as well as the pause between the notes. So in order to make it look more realistic. And void loop has been ended. So there is nothing to repeat over until you want this whole song to repeat again and again. So yes. Then we continue with the presentation. Next up, we have potentiometer. So reminding you of Jay stuff, what is a potentiometer, the slider contact, and all those stuff, which I don't want to do. I'll give a brief description. Potentiometer is a 3-terminal device wherein you have the central pin devoted for the slider contact and the other 2 pins for voltage inputs, which acts as a voltage divider basically. So how does that happen? Just as a recap, the resistance value would vary proportional to the displacement of the slider along the periphery of the model. So if it is a circular potentiometer like the case we have, or from Ajay and the meter bridge potentiometer that we've been discussing in questions a lot of times, it can be rotational or linear. So again, in order to understand how this potentiometer can be useful, we'd be looking onto a project where we'd be using the potentiometer, again, an analog signal input giving, what do you call, a component to vary the brightness of an LED. So let me go to the same thing, but open a different circuit. I mean, I guess you guys can also do this. Go to the same thing, your old program will be stored, but the name that you need to remember, because you can obviously go into it and again change the name, but I don't, in my case, it is simpler that its name is not very much fancy, like exquisite, weird, LUF and all. Like if it, in case that happens, I'd suggest you to change the name to a value that is comprehensible. Yeah.
Can you just copy paste that code onto the chat so that they can just follow the earlier
Oh,
one?
yeah, sure. I'll do that.
Okay.
So I'll copy paste this code in the chat. If at all you missed out the
No,
code.
no, not this one, not this one. The big one.
Okay, that one. Yeah, sure.
Yeah. Okay.
Pasting this in chat. Both codes. Okay, I'll do that. Well, it depends on our wish to use the breadboard or not, but it's a general suggestion that we use a breadboard in a circuit in order to maximize the number of input ports that are available to us to connect a component. So let me go to a new circuit. Begin with a new circuit to discuss the potentiometer. So again, as before, we'll begin with the brain. Then we would need a breadboard in this case again because the three-terminal device might be the case that we occupy more of the points here. So I don't know. Let me just avoid that from happening. Potentiometer. Let me connect it here. So this wiper or slider needs to be connected to one of the analog pins. Let's say we connect it to A0 again, maybe. And you need an LED as was the case earlier too. Anode needs to go to an LED, I mean a digital pin. So let me take pin number 6 and give it a color code of red and cathode to the ground, color code of black. Then we need to connect one of the terminals of potentiometer to the ground. So let's say this is being connected to the ground. Is this circuit very much right? Like there can be error. Like I'm giving you the hint. Is this circuit completely right? Like is it a circuit that will work always? Provided that all the materials are in ideal condition, yet can there be an error? Right? Can there be an error, guys? If you're confused with the question, like is this circuit completely right?
Also,
So
guys, one small announcement. Like, can you just stay for 5 more minutes? We have a small quiz coming up after this.
yeah, really.
Yeah, that's it.
No resistor between any. Exactly. That could obviously cause a problem. So we need to give an LED here whose value depends on what kind of, or I mean, what is the voltage value of the LED that is inputted. So it's better that we take an LED resistor which facilitates the connection. So let me just pull this up.
And then you can just go a bit faster.
Yeah, sure. So again, beginning to initialize the pin. Let me initialize the pin number 6, which is the digital output pin to be L. And again, the analog input pin A0 to be A, let's say. And again, we'll need to take a variable which we'll be seeing in the code from now. Moving on. So pin mode for output will be the L or the 6 pin, which we'll be using. And A, oh, I've given A, it's A naught, from where we'll be taking the input. And again, for debugging purposes, we'll begin or initiate the serial monitor with a similar baud rate or the default baud rate. Here again, we'll be using the variable that is being used to take the analog input and feed it to the LED. So A, basically the analog read function or the analog input taken from the potentiometer is used as the delay time for your LED to remain in the particular state in this project. So we'll move that to the next line. So yeah, so what does serial.println do, guys? And is this statement right? So two parts of the statement and two parts of this line are a bit fishy in my view. That could cause an error. I mean, one part could cause an error and one part needs a clarification, maybe. So what are the two things? Exactly, /n. And regarding your this thing, the S is small. The question I wanted to ask is the case specificity of the programming language that's being used. So if at all this is smallest, it would return an error. So even this language, like many programming languages, is case sensitive. Now, since the one thing, I'm going to zoom out so that you guys are able to see the code as well as the thing. You can see that the potentiometer in our presentation was like this, but ideally should have been towards this side or the side that is connected to the ground for the input to be 0. And if it is towards the side which is connected to a higher potential value, it will take the input as 1. So beginning the code, since it's the high state, the delay is 1, which is basically 1 second. And if at all I spin this to 0, it will remain off for all the values. And if at all I keep it in the middle, which is 512 volts, 512 analog input, it will remain on for half of a second and remain off for half of a second. The values on this potentiometer vary from 0 to 1023. Again, 10 byte input. So that's how this should vary. So any doubts in the code and the functioning of functioning of the LED and potentiometer?
Yeah, I guess we can start the quiz.
Yeah. So moving on to the presentation, we have a last slide which would clear the doubt of you guys regarding that resistor that was used. So let's assume that you were giving an input from to one side of a switch, and the other side of a switch is connected to a particular value, let's say ground. And this input, when the switch is in off position, can take any value between the highest voltage possible 5 and ground, which is not often expected from, I mean, from a device point of view. So basically, it can take any value and that it can change from one value to the another directly. So these resistors prevent that from happening by allowing this to be connected to a potential. So what if this resistor was absent in this place and just we had a connection to the 5 volt? Anyone? I'll not take much of time. This is the final question. Guys? So I see no answers, but yeah, thinking on the lines of switch, if at all this resistor was absent, and when the switch closes, the circuit is shorted that the 5 volt is directly connected to the ground and a high value current passes and your input device can get damaged. So in order to prevent that from happening, we use a high resistor. And so this resistors, when these resistors, so both the pull up and pull down resistors are necessary for preventing the achievement of floating values as input when the switch remains open. And also they function as a path for the flow of current when the switch remains closed. And for and in the first case, when the switch is open, the input voltage is pulled up to a higher potential. And in the second case, when the switch is connected to 5 volts, the input voltage is pulled down to the ground level to create a defined logical level in a pin under all conditions. When the switch is open, especially what has been delivered through the slide. So yeah, there is a do-it-yourself task that's being given to you guys to use a pull-up resistor to create a toggle switch. Yes, be back to the quiz time. So give me 2 minutes, guys. Like I'll share the link for the quiz chat box. Meanwhile, you guys can ask doubts in the chat and by unmuting throughout the session. To use a pull-up resistor to create a toggle switch. Basically, we'll be sharing slides, but then yeah. Once you guys are done, yeah, the session recording will be shared. Who's link? Yeah, I'll give it in a minute. Like I'll just start the link. I've shared the quiz link in the chat. Have you guys joined the link? Yeah, I give the question, but then I'm 1% there. Have all of you joined? Just put an S if at all you've joined the quiz link. Yeah.
Yes, and then you can start now, I guess.
Yeah, so I'll begin the quiz. Has the quiz started for you guys?
Can you share your screen if it's possible to show the quiz?
Yeah, 1 minute. One problem is the rest of the questions are also visible. That's why I'm not sharing. Oh yeah. Okay. There we have it. So in the screen, is it okay? I hope it is. So
Yes,
the
it's
next question.
Mm.
Good job, guys. Let's
Yeah,
finish
nice.
with the
Most
leaderboard,
of you got.
which is back then, so neglecting that. Christian is at the top. So yeah, guys, look at the timer and then move on to the question. So when I said to look on the timer, there is a bit of catch in this question.
Yeah, this is multiple choice, right?
Yeah, that is the catch.
Yeah, okay.
So,
Yeah, this is a multiple choice question. Yeah, so A and D are correct. Nice.
leaderboard once again. So this question was morning. The question at the top. Then Pranav, then Christian moves down a bit. Okay, wait, 3 or 4 seconds. Yes. Continue the bit. This.
You
Yeah.
can show the leaderboard at the end, no?
Ah, yeah. Fine. That also looks good.
So ADC is analog to digital converter and DAC is digital to analog converter.
So for this question, the analog input pins in the Arduino board take in the analog input and convert it to an equivalent digital input and then give it to the Arduino, internal part of the Arduino. So that is because of the presence of internal ADC, which is analog to digital converter circuit. Yeah. So this question, the main function, what I mean, or what we meant by the main function was the function that you would find in almost every programming language, let's say to C, Python, you would have a main function. And is it there in the Arduino programming language? But unfortunately, the answer to know why is it loading. Like for you guys, has the answer been phrased or it's still loading like the way it's being shown to me? Let me just go to the previous question and come back to this question. Oh, but
Yeah, it's still loading, it's okay.
yeah. Or maybe shall I say the answer for your experience?
Yeah, just tell and explain the answer.
Yeah. So the answer is an S. Arduino codes are built on a particular programming language, and that programming language has main function, which is not specifically or explicitly available or explicitly visible in the Arduino code that we are using. So yes is the answer, but on an overview, by looking at it from outside, it might not be visible is what I meant. So yeah, getting to the next question. Nice that you guys paid attention to the session properly. Yeah, this question again is interesting, which requires your attention on to the Arduino board, and it required to because but then covered it in the lecture. I need leaderboard for this question specifically. Who is it? Akhilesh. Yeah, nice. So it's Akhilesh who will be telling us, not only Akhilesh. Yeah, only Akhilesh. Yes. Akhilesh will be telling us which are the pins in the chat, which are the PWM pins on the Arduino board. Basically, the pin numbers near which the tilde symbol is present. But right after question, not now. Right. Great. So again, going to the leaderboard. Frank Christian has got up from initially he was at top. So I want him to find out which are the pin numbers which are used for TX and RX purposes. I mean, respectively, and put it in the chat. Going to the next question.
You'll probably have to take a wild guess for this.
Sure. Well, it doesn't seem they don't know. So the answer, good. And yeah, this question is really interesting. How many of you guys have been to Mega Session 2.0 or any Mega Session? I mean, after the quiz ends, maybe. Well, that's something expected. It's actually Java. So during the Mega Session, while they were sending the code on the top towards the right, so when you upload it on the GitHub or take it from the GitHub, it would be written Java. When I expected it to be C, but then it was Java. Now to Akhilesh and Krishan. Krishan is given the answer. Yes, Akhilesh also did. Hope he's typing the answer now. Going to the leaderboard. Krishan stands at the top. Akhilesh to the second position by minutes delay. I guess, yeah, when I was telling, he thought I wanted him to tell it right then only. So maybe that was the reason for him to push down. And again, Ravi Teja too. Great job, guys. Expected. Yes. So coming back to the presentation. Yeah. The link of the doubts form is in the slides. I'll be sharing it here again. So that you guys can copy paste it to somewhere, then send it out. Yeah, thank you guys for being in session with us today. This being the first session, start for a big
Yeah,
journey.
thank you. Yeah, thanks a lot for joining today. And like, very sorry for the delay of like my internet connection was very bad in the beginning. That's why.
And yeah, a special thanks to the patience that you guys had to listen through the session as well as wait to the start. And yeah, that's all we got to say. But is that the case? Like, can one of you again, other than Rohit, check if it's working? But it's not working properly for him now. Okay, you need permission. I'll try to send it here again. Check if this is working. Or maybe if at all this doesn't work, we'll share the slides to you by today. Click on the form then, and then try to send us the doubts that you have. Ruth, can you check if it's accessible now? Again, it's the same. Oh. Yeah, then that's the only way we'll be sharing the slide. While we are sharing the slides, we ensure that the control is given to you guys to ask about. It's fine with you guys, right? Hope it is. That could be a reason, possibly.